What's inside a black hole? As we embark on an incredible journey into the mysterious depths of the universe, one question looms larger than any other. What lies inside a black hole? These strange cosmic entities have fascinated scientists and captivated the human imagination for decades. To comprehend the inner workings of a black hole, we must first understand their formation. Black holes are born from the remnants of massive stars that have reached the end of their stellar evolution. When such a star exhausts its nuclear fuel, it undergoes a cataclysmic explosion known as a supernova, leaving behind a dense core. If this core has sufficient mass, gravity overwhelms all other forces, causing it to collapse in on itself, creating a black hole. At the heart of a black hole lies a region known as the Singularity. This extremely small point defies our current understanding of physics, where the laws of nature break down. The Singularity is thought to possess infinite density, meaning that matter is compressed to an unimaginable degree. It is here the laws of space and time lose their meaning and our knowledge reaches its limits. Surrounding the Singularity is the event horizon, the infamous boundary beyond which nothing, not even light, can escape the black hole's gravitational grip. The event horizon acts as an impenetrable curtain, trapping everything that crosses its threshold within the black hole's clutches. As matter falls into the black hole, it forms a swirling disk known as an accretion disk. This disk is composed of superheated gases and particles spiraling inward, releasing immense amounts of energy in the process. The extreme conditions near the event horizon give rise to mind-boggling phenomena. Time itself becomes distorted as gravitational forces warp the fabric of space-time. This effect, known as time dilation, causes time to slow down for an observer outside the black hole, relative to an observer near the event horizon. Objects approaching the event horizon experience a stretching of their structure known as spaghettification due to the intense tidal forces acting upon them. But what happens to matter once it crosses the event horizon? The answer lies shrouded in theoretical speculation. According to general relativity, as matter plunges into the black hole, it eventually reaches the Singularity, where it is crushed into infinite density. However, the Singularity itself poses a fundamental challenge to our understanding of physics. It represents a point where our current theories break down and new physics, such as theory of quantum gravity, may be necessary to fully comprehend its nature. One intriguing possibility is that the Singularity is not the end, but rather a gateway to another realm of existence. Some theories propose the existence of wormholes within black holes, hypothetical tunnels connecting distant regions of space-time or even different universes. These wormholes would offer a potential escape route from the clutches of a black hole, leading to other corners of the cosmos or perhaps even to parallel dimensions. Another concept gaining traction is the holographic principle, which suggests that the information contained within a black hole is not lost but is somehow encoded on its surface. This principle is derived from string theory and quantum mechanics. In recent years, advances in observational astronomy have provided us with new insights into black holes. The first ever direct image of a black hole's event horizon, captured by the Event Horizon Telescope in 2019, revealed a dark figure surrounded by a bright ring of light emitted by the superheated matter in the accretion disk. This breakthrough observation confirmed many theoretical predictions and opened up a new era of black hole research. While we have made great efforts in discovering the mysteries of black holes, their true nature and what lies inside them continue to puzzle us. The singularity remains a mind-boggling realm where our current understanding of physics falls short. As we push the boundaries of scientific exploration, we will continue to refine our models, develop new theories, and seek innovative ways to peer into the heart of black holes. If you liked the video, please give it a thumbs up and subscribe to the channel for more amazing content. See you soon.